Today we're going to be looking at the life cycle of an asset and the importance of understanding the life cycle of an asset. Now, when we look at this image over here, we can see that this image contains countless assets that have been procured by companies to enable their production processes. And of course, these companies have spent really huge sum of money, and so nobody would want to spend multi-million dollars on assets and making it go into waste. This for production companies would mean low production turnover and the massive loss in their capital investments. And so, to properly do this, they would have to be able to understand their assets holistically. Now, let's take a look at what we call the asset life cycle. From this image, we can see countless assets like I had already explained. There are certain cycles that this particular asset have to be able to go through before the decommissioning stage, and I'm going to be taking you through that. Now, the first stage is this. For this particular asset to come into the supply network, we first of all have the project planning. In the project planning, the particular business has to draw out a business plan. And most of us already know what a business plan is, but I'm going to try to explain what a business plan is. A business plan for the organization will be able to let the organization know what they want to procure. Why do they particularly need this asset? And what will be the cost of this asset? Now, when they are able to answer these questions, they have to be a discussion between the business and the original equipment manufacturers. In the discussion, they look at the user requirement specification. Now, why do they need a user requirement specification? Every particular organization has unique processes, which is basically what distinguishes one organization from another. Okay, so when this particular discussion is made, the organization lets the original equipment manufacturers know the type of products that they produce and how they have to manufacture that asset to suit their processes. After this discussion is done, then we begin to draw out the budgets that are going to be responsible for the procurement of these assets. Before these assets are being brought into the supply network, there are several asset testings that this particular asset has to go through, demos, trials, and the main reason of this is to make sure that that particular asset coming into the supply network can be able to suit the organization's need. After this particular asset has been integrated into the network supply, then we look at the material master data. This asset that has been integrated has to be maintained because they run continuously. Okay, so they have to be maintained. So at this point, we maintain the master data relating to the assets. When we talk about the master data, we look at the functional location, we look at the bill of material, we look at the equipment structure, because surely we have to be able to have a history. Also, we have to align the document management system. Sometimes original equipment manufacturers have some documents containing some type of maintenance that they might specify for the particular assets. So we create our document, and these documents are attached to the functional locations. After the master data has been maintained, then we begin to define the maintenance strategy. In defining the maintenance strategy, there are several things we look at. And one of those things we look at is the operating hour of the particular assets. There are some particular assets that are designed to run for 24 hours based on the type of operation that a particular asset goes through. And there are some type of assets that are meant to run probably for 20 minutes or 10 minutes, depending on the process. These are factors that we look at when we try to define the maintenance strategy. One other factor we look at is the machine criticality ranking. Yes, in a particular network, we have a lot of machines, but there are some machines that are very critical, okay? So these type of machines enable us to be able to have a proper decision when defining our maintenance strategies. This particular asset that have been introduced into the network also have to be maintained. And so we have to maintain a material list for them. Of course, when the original equipment manufacturers bring in this particular asset, they come with spare parts that they have suggested for us to use in the maintenance. And so at this point, we have to be able to create a material list for these particular assets. And then we also have to define the maintenance budget, because for every maintenance that is going to be carried out on that machine, a particular budget has to be defined. After the master data has been maintained, then we begin to generate maintenance schedules. And the reason for doing this is this particular assets that are being brought into the network has to be maintained. So they have to be an instruction, or can I say a task list, a schedule that has to be created for the maintainability of this machine. Now, this particular task list are put in work orders. When we are defining the work orders, the task list, we also look at generating predictive maintenance instructions. Okay? Apart from the predictive maintenance instructions, we also have technical failure instructions that we also have to generate, and the inspection-based instructions. Now we have our instructions that have been generated, then we move into the execution of the work execution. At the work execution, work orders are created, materials are included in the work order. And at the end of every maintenance, a particular work order is confirmed and technically completed. Apart from the execution of the particular job, the performance of the machine also has to be measured. And how are the performance of the machines measured? Now, when we have our functional allocations that have been created during the stage where we define the master data, if we continue creating work orders for those particular assets, over time, we are able to get a history. So for every particular breakdown that asset has, we are able to get a particular history on SAP from the functional allocation. Now, with this particular history that we have gotten, we can be able to properly measure the performance of that particular asset. From the history that we've downloaded, we can see how many times a particular machine has a breakdown. And then we begin to analyze the breakdown to reduce the recurrence of this particular breakdown. Of course, the life cycle of an asset is not complete without the asset disposal stage. At this point, this particular machine has outlived its useful life and is due for decommissioning. We have some machines that run as far as 35 years, 40 years, 20 years, 10, 15. And at a point, we begin to experience a decrease in the production from the particular asset. At this point, this is the point where it is known as the decommissioning stage. At this point, this machine is due for disposal and ready to be removed from the supply network. So I want us to take note of this. It first starts with integrating these assets into the supply network and ends with removing these assets out from the supply network. Now we are able to understand the life cycle of an asset. In understanding this, we can be able to then make proper maintenance decisions. See you in the next video.